In this video, we start digging around and trying to find answers on why a customer has had a solar PV system installed and why they aren't seeing any savings. So we analyze data and look at real-time values in order to understand where the potential issues on a solar installation can be and why this particular client is not seeing any savings. Let's start with a bit of background to this installation. We have some updated information that is going to show us what the load profile is, what the KVA is, and what the consumption is, and the municipal bill. This particular customer is an Eskom customer, and they are operating on a tariff that is called land rate. Quick look at this site. The site is on a wine farm. Meter sits over there, 100 kVA transformer. So it comes into the property through this transformer over here, through the meter, and then goes through a step-up transformer. You would be surprised at the consumption that a transformer has just in operating. The 100 kVA transformer supplies medium voltage to another step-down transformer, and at this point it is stepped down again to 400 volts, where the load splits to a house and to the wine cellar. So we have two solar systems and one incoming supply. So what is interesting? Let's just try and understand what we are looking at. This particular graph on the y-axis shows us two values. It shows us both kilowatts and kVA. We can see at the bottom is a legend, and the red line represents kilowatts and the blue line represents kVA. This particular load profile was done for Tuesday, the 20th of May, and it shows data from 12 o'clock at midnight up until 12 o'clock the following day. So it's a 24-hour cycle. Where we could maybe start is this section over here. Let's take it up until 3 o'clock in the morning. We can see that point over there showing us that this particular site consumed 4 kilowatts in the morning from about 12 a.m. up until 3 o'clock. Let's go and have a look and see what the Daya Inverters app is going to give us. Now, if we look at the SolarMan app, there are a couple of things that I would like to focus on over here. One is the data we are looking at is the 20th of May. So it's the same date as we see on the load profile. Okay, so what's interesting about the Solar Systems app is that the load remains constant at 2 kilowatts up until about 9 o'clock in the morning. However, if we go back to our load profile, we see that at 4 a.m. in the morning, the load increases and shoots up to about 8 kilowatts. So what it's showing is that this solar system shows a constant load of 2 kilowatts until 9 a.m. But where we had the meter installed, which was in this section over here, it shows that it went up to 8 kilowatts. So the only place where that power could have gone would have been to the house. Something else that is interesting is that throughout the day, despite the fact that we've got a solar system installed, our KVA remains the same throughout the day. So we have a KVA problem. We have a power factor problem because our load is 4 kilowatt, but our transformers are burdened with 44 kVA. And that 44 kVA pretty much stays constant throughout the day, even when the solar is present. So even if we look at this section over here, let me change that to a block. Even if we look at that section over there, we've got the solar system producing power and reducing the consumption down to 4 kilowatts, but our power factor, our demand on our transformers remain 44 kVA. Next thing I want to quickly have a look at is this section over here. From 8 to 9, we see a massive spike. Was that at the cellar or was it at home? If we jump through to our SolarMan app, we don't see that spike anywhere. Something that is extremely important over here is the logging frequency, or the rate at which the Daya inverter or the SolarMan app samples data, because it only takes a reading every 15 minutes. So the information that we see over here might be slightly skewed because it's not going to capture the spikes on this particular app. What we can see though is we can see that the load increases to about 3 kilowatts. So the load sits at an average of about 3 kilowatts until about 4 o'clock in the afternoon, and then it steps up to 4.5 kilowatt. Let's go and have a look. So we've got 3 steps. We've got 2 kilowatts until 9 o'clock, 3 kilowatts until 4 o'clock, and 4 kilowatts for the rest of the day. On our logger, the data looks completely different. Let's just draw those blocks. 2 kilowatts until 9 o'clock, 3 kilowatts until 4 o'clock, and then we've got 4. So I'm just kind of going with the mean or the average value of what I can see in my graphs. If I look at my graphs and I have to average those red lines, now I'm kind of thinking that's where the average is going to be. So what we are measuring over here is 6 kilowatts in the middle of the day until 4 o'clock, and then 12 kilowatts from 4 o'clock to 12 o'clock at night. So those are 3 distinct steps, and the difference we see is double, or is more than double than what the SolarMan app recorded. Is more than double than the values recorded on the Solar Systems app. So what I'm thinking, where some of those losses are going is into that transformer, and what we don't have is we don't have the data for the home. The KVA, I think undoubtedly the KVA issue is generated by a load at the wine cellar. We'll have to find the KVA issue. So the big issue is KVA. We need to find where the issues are on the power factor, and then we need to try and find where the losses are. If the losses aren't there at this transformer and at that transformer, there has to be some additional losses that are not accounted for either at the wine cellar or at the residence. We are going to the site again soon, and we will do a follow-up video as soon as we've dug around a bit more, found more information, and we'll be back to show you guys what's been done, what we found the issues were, how they were resolved, and what the result was. Before we do that, let's have a look at one more day's worth of data. Guys, what I find that's interesting, have a look at every single day. Apart from that one, do you guys see what I'm seeing? Have a look at what happens over here. For every single day, in the middle of the day, the solar power production is cut down to 3 kilowatts. Have a look at the previous day, and the previous day, and the previous day, and the 28th, and the 27th. Fine, we've got some bad weather over there. So guys, if we look at this profile that we've identified, we'll see what happens is that line there lines up with the charge curve. So the curve at the bottom of the page is the state of charge. What this shows us is while this system is charging, the solar system is producing power, and that curve is consistent with the different days. So if we skip to a different day, let's just find one. There, the same thing. That line is consistent with that point over there. So as soon as the system reaches 100% state of charge, the solar system cuts out. But what is notable over here is that that line there never goes away. So the consumption of 2 kilowatt never goes away. When we look at the 2nd of June, we see that the load in the middle of the day has increased to, and maybe we should just annotate this quickly. Let's just draw a line. What I want to show is over there, the blue represents our power that's being produced by solar, and the red represents our load. What we can see is that this line, this first orange line I drew, kind of runs along with the battery charge rate. What we see when we look at the load, which is the red line, it doesn't seem as if the power being produced has any impact or effect on the consumption power. So what this is telling me, or what I'm reading from the graph, is that all of the power that is currently being produced is being used to charge the batteries. The batteries run down during the evening, so the batteries must be servicing some kind of load, but that load is not represented in this graph. What we can take away from this is that the stringing might be fine, but we might have to consider where the CTs have been placed, and we might have to consider making some adjustments to the settings. This is going to be interesting. If you want to see the update after we've done the fault finding and we've identified some of the issues, as well as what we've done to mitigate those issues, and how we've assisted the customer to find why the solar system is not saving money, like and subscribe, and you'll get an update as soon as we publish part 2 to this series.